heart rate monitor, and the circuit involves filters, op-amps, a differential amplifier, all these sorts of complicated components, which we'll explain to you. But she managed to turn out a working circuit, and she even managed to modify it after figuring out the circuit and getting a pulse.
It's not one of the
Sorry.
modifications.
So the webcam's up, so as soon as you want to use it.
Okay. Hello, I'm Sophie. I'm a rising junior at Urban. Yes, another Urban kid. And I, for my starter project, I made a voice changer where you speak into a microphone and the pitch of your voice comes out, but it's way different than how you spoke into it. And for my final project, I made an EKG heart rate monitor. And so basically I have a pulse sensor on my finger, and how that works, how it reads my pulse is there's a little bit of light in here and you can't really see it, but it shines it on my finger and it detects how much blood is in my finger. And since I have low blood pressure, not much light is actually shined back, so it's kind of hard for my heart rate monitor to read the signal of my heartbeat. So often I have to have caffeine in my system, or we use Jesus because it has high blood pressure. So I have to run the code. Okay, this is projecting now.
Yeah, if you move the computer.
This thing?
Yeah.
Okay, oh, okay.
Oh, and it's partially blocking the projector.
Yeah. Whoops.
Just get the camera close. It's not-
Okay, well, I can kind of see it. Okay, there we go. And the line's really faint, but what's going on is my heartbeat is actually being displayed on the screen right now, and my beats per minute, my BPM, is being counted, and currently I have a BPM of 90, and there's actually a diagnosis I have on the bottom depending on what your beats per minute is. So if it's kind of, well, really low, it says, "Where is 911?" And if it's really high, it says, "Cut down on the coffee, buddy." And so how it works is I actually explained the pulse sensor. So a signal goes through my pulse sensor, and what I didn't know when I started this project is that a heartbeat is actually very, 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 very small. And so it goes through two amplifiers, which makes the signal a lot larger, and actually goes through my circuit. And it ends up being read by my Arduino, and the code I actually had to rewrite from scratch for my Arduino because it is originally made for an LCD, and I use a TFT, and the difference is that a TFT you can actually code for a lot more there's a lot more pixels on it, and the graphics are a lot more in detail. And so the signal goes to my Arduino, and I actually had to write and teach it how to count the beats per minute. And then that is sent to my LCD screen, and it displays the signal from my heartbeat and my beats per minute, and gives a diagnosis. So one thing that was really challenging was the electrodes. I know the instructors had a lot of trouble with me with this, but we actually went through, I think, about 5 different electrodes, and we started with a paper clip and foil, and this is what we ended up with. And we placed it on either my wrist, chest, neck, biceps, and finally finger. And this is the one that had the most reliable signal. So my modification is that it's not supposed to, the heartbeat is actually supposed to be displayed on an oscilloscope, and that's like a large machine. And what it does is it displays a current that it's getting, and it displays it on the screen. So if it was getting a heartbeat, it would display it on the screen of the oscilloscope. But that thing weighs a lot, and nobody wants to carry that around. So I actually have it displayed on my TFT, and it's a lot easier and a lot more mobile. And I also built a wall and a platform because every day I'd come in and a different wire would be sticking out, and I wouldn't know where it's going to or why it had come out, and it's very, very fragile. And so I built this so that none of the wires come out. And I'd say I came to Blue Stamp actually interested in electrical engineering, and I come out and I'm more interested in biomedical engineering, because the reason I built this was because I was interested in a heartbeat, and I thought it was a lot larger, and I always seen it at the doctor's office or in hospitals on screens, and I was like, oh, how does that work? And figured out that it's actually just a signal, and it's read and amplified a lot. And it's really interesting to see something that's on that inside of my body displayed on a small screen.
Any questions from the audience?
What was the most rewarding part?
Probably the day that we saw a heartbeat on the oscilloscope, because that took us 2.5 weeks to get to.
What were some of the techniques used to try and debug your circuit?
So one I used is a function generator, which runs a current through my circuit. And when we didn't know why the electrode wasn't picking up the signal, we thought it was, oh, it's the circuit, something's wrong. And we actually ran it through, we ran power from the function generator through my circuit. And we actually saw that it was all the electrode not picking up the signal, because the signal is so small. And so we ran a current through it, and we actually saw the current on the oscilloscope, and so we knew there was actually nothing wrong with this circuit, it was just the electrodes. And I also used a multimeter, which I only used it so that I could see where the connections were on my circuit, and it actually, the mode I used, it actually beeps when it senses two things that are connected to each other, and there's a signal going between them on the circuit.
How did you check it's accurate?
Oh, that was really hard, because you can't just be like, oh, I know that's a heartbeat, like that's a shape. I had to code it from a line that it actually hits on my TFT. So there's a certain point at which a heartbeat is above a line and it starts below one line. And what I did was every time it changes from being below this point to above this point, that's the tip of a heartbeat. So that'd be 1 beat. And I did that every 6 seconds and then multiplied it by 10.
What's a TFT?
It's also LCD, which is liquid crystal display, but it's just more advanced, and you can have more in-depth display. So instead of just having my original LCD had about 16 squares on it, this thing is 320 by 240 pixels instead of that.
Sorry, Sophie, but did you say the transdermal sensor on your finger, you made that yourself, or did you?
No, this was after trying to make many, many different electrodes. We had to order them after a while,
Okay,
and so this was the last one we ordered.
but you tried to make that.
Oh, yes, I did.
With what?
Oh, well, originally it was a paper clip and foil, and that conducted, but it didn't amplify. It didn't go, the signal did not travel through well enough. And so then we went to a massage